Okay, so what if I do this again, but I make everything smaller? Hey guys, CWHello1 here. Welcome back to another video, and today, we're doing another Blunami upgrade, except this time instead of putting it in a behemoth of an SD80 Mac, I'm going to be testing my packaging skills and seeing how small I can make the Blunami package that I had made, and stuff it into this Atlas O SW9. So this is a Atlas O SW9. It's got the die-cast shell. It's really nice. It had Engineer on board on it, and this belongs to my friend who hosts operating sessions essentially monthly. And at the last operating session that this one was running at, it decided it wanted to have a little bit of a runaway moment, and it just set itself off at speed step 1. Went down the track, found the first switch that was thrown wrong, bridged the center rail and the outer rail over its pickup rollers, and decided it was just going to melt itself and literally catch on fire. There was smoke pouring out of this thing, but it completely wiped out the engineer on board motherboard. Like, the resistors that were on it, like, literally exploded. All that was left was just the wire that bridged the connections that the resistor part goes on. This thing didn't have a great time. You can actually see these are the triacs for the engineer on board. But I am eventually going to try and rebuild that board. It's probably futile, but, I think it'd be fun. And I'll record it if I can get it to work. But odds are that's not happening. But I'm going to give it a shot. So yeah, this thing got completely cooked. Surprisingly, the RailSounds power board, the RailSounds board, and the R2LC all work, even though they are completely fried. I might make these another, like a short or something. But they got totally cooked, but they still work because those electronics are literally bulletproof, apparently. Well, they're fireproof, apparently. So, yeah. But for this purpose, I'm putting the Blunami in it. I just need a motor and a working drivetrain. I've got most of the pickup rollers left, and all the other electronics that are going to be going in it are new. So that's a really heavy frame, actually. We're going to try and shove all that into here, same as I did with the SD80 Mac, except smaller. So as always, the first thing is to gut the engine, but as you can see, most of the work's already been done, so I'm just going to take out the last little bits that are left and start trying to fabricate some mounts. You want to talk about a tight squeeze. I couldn't actually get this assembly to fit into this engine. I was going to test if I need the capacitor if I'm using the buck converter, but I only bought 2 of these rectifiers and the other one's in an SD80, so that's just how that is now. But it's fine. It's better for it's good for a road engine or something, or a steam engine. But this is a AC to DC voltage regulator slash converter that I got for the lighting circuits on my layout when I was getting it ready to go to Tiger Tracks. And the shell is on, and that is rubbing against, well, almost rubbing against the top of the underside of the frame. So really, really, really tight fit. But it fits, and that's what matters. Here's what that board is, by the way. So this is a 5 volt to 32 volt input that drops it down to between 5 and 18 volts, I believe, or 3 and 18 volts, DC. So AC input and DC output, which is really nice. So it's a rectifier and a regulator. So it's basically that, just that big. So very good for small projects. Again, I got these for buildings. They fit really well underneath the platform, and this fit really well inside of my lighting controller. So that's why I've got these. If you want to go check out that video, you can see the original use for this. But I think I need to figure out how exactly I'm going to mount this. I had it sitting on top of the motor with the intention that the Blunami board would go here. figuring that would be a decent-ish layout. But I really can't use anything, you know, like there back, because that's where the cab goes. And the cab has an interior that's really nice. So it's just this foam cover that I don't know why it's here. I don't really want to take it off, but also I may need to attach this to that motor. Meaning I'm either going to just tear this off and put on some double-sided tape, or I'm going to have to 3D print some sort of round bracket. But I don't know. I'm going to play with it some more, see what fits. Also, I was toying with the idea of putting electrocouplers. This is a switcher, so, you know, having the electrocouplers would be nice. But to do that, I need AC voltage. I did test this with a 9-volt battery, and it doesn't do anything. Doesn't matter which way you have the leads hooked up, that electromagnet will not fire with the DC battery. So when I hook it up to AC track power, it fires just fine on super low voltage. So what I think I'm going to do is eventually I'm going to get, not in this video, but sometime down the road, I'm going to experiment with getting relays. So DC triggered relays that have an independent through, so I can put an AC through on a DC triggered relay so that the function on the Blunami output can trigger the relay, and that will send AC voltage, probably track voltage, straight to either the front or rear electrocoupler, so it'll need 2 relays. But that's the idea. You could maybe use a like a transistor or a triac, or maybe not a triac, but like a MOSFET. I don't know enough about it to know if I can run AC and DC into a MOSFET without blowing it up, and I don't really want to experiment on this particular engine because it's not mine. So, anywho, I'm going to keep tinkering with packaging and see if I can get everything to fit. So here's what I ended up going with. This is a heck of a lot smarter. This platform is lower, and yes, it's covered in electrical tape, so that nothing shorts, but that gives me a lot more clearance for this capacitor, and then the Blunami board went on the high spot, which happens to be on the motor, so hopefully that motor doesn't get too hot. I guess we're going to be testing the thermal limits of the Blunami board here. But yeah, getting that foam tape off, not fun. It came apart in like a million pieces. Ignore the red. Anywho, I have the negative hooked up. I'm going to reconnect what's left of the pickup rollers and see if I can fix the one that's bad. And then I should have AC positive in, and then I can tap these 2 ports here for my DC output, which go right into motor left and motor right. So whoop-de-doo. Yeah, I'll keep going. Yeah, so here's what's left of the pickup rollers. This one honestly doesn't look too bad. This is the one that got bridged, as far as I can tell, and it is smoked. It's actually really nice. When Atlas designed this whole bottom plate here is plastic, so I don't have to worry too much about the electrical isolation. But here's what I mean by what's left of the pickup rollers. So this is one set. As you can see, it still does the thing. This is the one that was up here. Here's the other set. As you can tell, one of these things is not like the other. This guy is all flippy floppy. So I'm going to try and pull that spring and bend it back into shape, and then mount that back where it goes. So yeah, I was able to just pull open that tab, pop the spring out, bend it back with some pliers, and now I have a sprung pickup roller again. So pretty simple fix. So I'd probably give that like a 2 out of 10. Would not recommend. Putting pickup rollers on a melted truck, not fun. The screws don't really bite, so what ended up happening was I had to put a layer of super glue on the bottom of the pickup roller to hold the pickup roller to the truck, and then I had to solder the lug for the pickup to the pickup roller. Obviously, this is not great. When you vaporize super glue, it creates a lot of fumes that are really bad. But thankfully, I don't think I got it that hot. But it was pretty warm. I did burn myself pretty good on the front pickup roller when I was trying to set up the second one. But yeah, so that's how that's done. So I now have pickup rollers again, which is great. So I can run those into the board up top and calibrate my voltage. And I might hook up the speaker tonight just for fun. I might do the motor. I should probably measure the stall current. Somebody commented on my SD80 video that I didn't measure the stall current for a dual motor setup, which I should have done because the Blunami board can really only handle like 4 amps going to the motor. And apparently this person had tested one of their motors at like 6 amps for stall voltage, which is that's a lot for O scale, and that would obviously fry this board. So I don't think it's going to matter too much because it's a single motor configuration here, but I'll probably find some way of jury rigging it and testing it out because I don't have the original electronics to just hold the wheels, turn up the voltage, let it stall out, and then measure the current that's getting fed to it. So yeah. Anyway, that's that. So let's keep going. So I've got the voltage calibrated to, you can actually see the light fading out now. I got it set to like 17.9, 18-ish. Originally I was going to run it to these 2 output pins on the back, but those don't do regulated voltage. That's just straight 28 volts or 25 volts, which I believe is max. This board will handle that. It goes up to 27. I like it being lower, so I think I'm just going to run slightly longer wires out of this terminal over into the right and left rail. So I have to throw away my nice short leads that I made to go from here to here and make some longer ones. Don't you love when you're like halfway through a recording and several hours into a project and then you realize that you're using 30 FPS HD instead of Ultra HD 60 FPS? Yeah, whoops. Sorry about that, guys. Anyway, I just spent the last hour pulling the whole motor and driveline apart and then putting it back together so that I could move the speaker wires to the other side of the motor so that they'd be easier to connect to the board. Yeah, this stuff is... It's nice because I like all the screw terminals and whatnot, but oh my god, getting it all set up is definitely what takes up all the time. But anyway, I've got power hooked up, I've got the speakers hooked up, and the motors are hooked up, but I can't test the motors while recording because I'm using my phone. Anywho, let's power it up and see what it does. That's a good start. You know, for a little tiny, like this big, tiny, half-watt factory speaker, that sounds pretty good, especially given that the shell's not on it, which is basically the speaker baffle, because there isn't really a way to seal that chamber. You guys can't really see it, but I got the motor the right way around on the first try. The wheels are going forward, and it's in forward, so huzzah. So it's got lights now. That's the dim light. I have them set to the auto dim reverse and forward for the opposite end. So this is on auto dim reverse. The other one's on auto dim forward. Also, yeah, this thing's noisy. It doesn't have a cab light. It only has a headlight and a backup light. I asked my friend if he wanted me to try to put in a cab light, which would not be easy on this engine. He said, don't worry about it. He runs daytime op sessions anyway. So, cool. Don't have to worry about that. So the only thing I'm waiting on here are the boards that I designed for the couplers. So first off, my apologies for the terrible audio. This is why I don't do a lot of computer audio stuff. But what you're looking at is the circuit, the final circuit that I developed for the Blunami electrocoupler control system. This works. This is actually, I'm recording this after I just did a bunch of stress testing at my friend's place. He now has the engine, and we know that this works, and there's one note that I'll get into a little bit later about the circuit. But essentially what this is it's a mechanical relay down here, and in order to activate it, you have to pass a current through the electromagnet or the coil that's in there. So when you open or close this switch, it either charges or discharges this capacitor up here, this 100 microfarad capacitor. And now when capacitors are charging or discharging, it creates what's called a voltage potential across it, and that is what generates a current, which creates an electromagnetic field, which closes the relay. So if I close the switch here, you can see the current moves a little bit, and that closes the relay for a second, and then it reopens again. And the reason it does this is to allow you to use a toggle on-off input to have a momentary output. Now, later in the video, you'll see, I kind of freaked out for a second because there was a momentary option that you can set up if you're using the app on Android. You can make the function buttons momentary, which eliminates the whole purpose of this circuit. But on iOS, which is what my friend has, I can't figure out how to do that. So for an iOS system, it's just an on-off input. There's probably a way to make it momentary by changing CVs, but I couldn't figure it out. So this is actually, I'm glad I did this, because for an iOS user who doesn't have the ability to just make it a momentary switch, you can't just use the relay, like I say later in the video. You have to have some sort of circuit like this, unless you're okay with quickly turning it on and quickly turning it off. But yeah, so this circuit will toggle your relay. The note that I mentioned earlier has to do with this 100 ohm resistor up here. So as you can see right now, the function is equivalently on, and as it's on, the current is flowing through this resistor constantly. So this is the only load on that circuit, so this resistor is going to get hot. Now, I did the math, and it came out to like a 3.5 watt resistor, I think, that I needed to not blow it up. So that's about what I put in it. Now, the problem with that is that it gets really hot. So when we had this in the engine and we were testing it today, we had left the function on, which is not something that I had tested when it was here at my place. And the resistor actually got so hot that it started to melt the flux in the solder that I used to make the boards. And it started smoking, and I thought for sure that we had cooked either the resistor or the capacitor or the Blunami board, which is worst case. But as we had the shell off and we were looking at it, and it started to smoke again, it smelled very strongly like flux and solder. So that's how hot this thing got. Don't touch it. I learned that the hard way. You can probably fix that by putting a higher wattage resistor on there. I think that's how that works. I'm going to, for my next revision, I'm going to like double the wattage on that resistor if possible, to try to keep the heat down. It does make the shell nice and toasty, so if you're looking for a hand warmer, you can use this. But if it like touches a wire or something, it'll melt straight through it. So that's the only caveat with this particular circuit, but it does work. And you can toggle a single pull, single throw input and control the relay, which sends power to your electromagnetic coil in the coupler, which is emulated by this light. So that's the circuit, and these are all the values that I ended up using for the relay that I got. And yeah, it works great. So anyway, on to the rest of the project. Okay, so I've been all over the place recently, and I can't remember what the last thing I did on this was, so I'm just going to give you a bunch of information, and hopefully future me doesn't have to edit it all out. So this is Rev 1 of the board. This does not work. So solid state relay means that I can't, it's not just an on off switch, it's actually just basically a really sensitive potentiometer. And I could never get it to fully open. The lowest I could get it to go was like 7 kiloohms, which is way too much. And also, this is a DC relay because I messed up when I read the part number. So I got a DC relay, which just doesn't handle AC. Also, this circuit design has no way of discharging this capacitor, so when you turn on the function, it does the momentary thing because the capacitor is charging and then full. And then when you turn off the function, the capacitor has nowhere to go. So it just sits there and nothing happens until you short it to either itself or to the negative end of the circuit. And then it discharges and it does the momentary thing, kind of. So, yeah. That didn't work. So, redesigned it with the circuit that I probably showed you guys. These are the boards for them. 4 components, basically. It's these little teeny tiny telecommunications relays. They are rated to 12, or they're a 12 volt signal, 12 volt DC signal that controls an AC load. And I know I'm giving it 18, but the surge protection on this is like up to like 60 volts, I believe. And the max voltage, when you math it out, it's like 16 or 17 for like continuous operation. So I'm not overly concerned about these just momentarily being turned on and off every now and then. I don't think it'll cause these to blow up, but I guess we'll find out. I'm reusing the same capacitor that I did on the old ones, and I have new resistors. I believe I have what are these? 100 ohm, it's a fat one, and 470, I believe. Yep. So the reason these are so fat is because this is the discharge side, so this experiences a lot of current like all the time. So yeah, but I'm gonna build one of these and we're gonna wire it up and we're gonna test it out and hope that it works, because simulation wise that should be fine, but we'll see how that goes. Okay, so I've got my setup here. I built the board and realized that I had mirrored the relay, so the relay's on the bottom. But yeah, that should just work now, hopefully. We'll see. So I'm going to first just put power. And with the DC relay, it would just throw the coupler immediately. Because it had no way of filtering out AC. So if I check my positive to negative, I have 17 volts. Sure. That should be enough to throw a coupler, and now I gotta real quick just make a 18 volt power supply. So 18 volt DC power supply. And let's see if I blow this up. Oh my god. Well, that's not the result I was expecting. The plunger is over here now. But that worked. Holy crap. I'm actually amazed. I did a circuit. Sweet. Now I gotta put it in that thing. I lie. I'm gonna do more testing first. I say do more testing. I already did it. I know what happens, which is why I'm showing you. I put a little bit of tape on the back of the coupler so that it doesn't... my fingers are tingly, that's weird. So it doesn't send the plunger off into space. And if I put power, turned on for a second, and then turned off. And if I release power, I can't believe that actually works. Like, I know that the math and the simulation and whatnot says that it should work, but it works. Oh, that's so cool. Okay. I'm really proud of myself. I am a mechanical guy through and through. Like levers, linkages, gearing, I understand that. Electronics have always been voodoo to me, so this is freaking cool. All right. That's a dummy, like, that's just a demo coupler that was broken off of my RS1. Now, let's go put it in the switcher. I wish I could record this, but I'll show you. I'm going to close this coupler, and if you know electrocouplers, you know once it's closed, there's really no way to open it unless you apply power to it somehow. That is a functioning electrocoupler in a Blunami equipped 3-rail locomotive. That makes me so happy. So my wire management of this isn't nearly as good as it was in that SD80. But, you know, it is what it is. This engine's going to be a workhorse. It's a switcher. That's what it does. And my friend does mostly switching operations anyway, so this engine is going to get abused. And odds are the shell's going to be off of it many times, so I didn't want him dealing with plugging and unplugging connectors all the time when you can just pop the shell on and off. The only thing that's connected to the shell right now is the lights, which don't have connectors, but maybe I'll do that in the future. These boards absolutely work. The front coupler is just a little lazy. The spring is a little weaker than the rear coupler. So when you fire the electrocoupler, it can't get out of its own way. And by the time the electromagnet deactivates, it's still in the locked position and it just kind of snaps back in. Most of the time, though, it's fine. And if you put your finger in here and fire it, it'll open. If you have a load and you're pulling it and fire it, it'll open. It's just like a normal 3-rail coupler. I'm sure us 3-railers are very familiar with how with the electrocouplers and their quirks. But the rear coupler throws no questions asked. It doesn't matter what you're doing, it fires. It's really nice. But yeah, it is also probably worth mentioning that as I was configuring the naming for these boards, or these function outputs, function 3 and function 4, I realized you can turn off toggle, and that just makes it a momentary. So you don't actually need this fancy circuit. But if you're looking to do that and you want to know what the relay is, this is the relay. It's a telecom relay, single pole, single throw, 1 amp, 12 volt relay, mechanical relay, and it works a treat. So if you want to use the momentary thing, that's all you need. You just need the pinouts. You control it on the DC side, and you run your AC on the switch side, and that's that. So I'll put a picture of the full circuit on screen if you guys are interested in recreating it. I used KiaCAD. I think it's KIA CAD. I don't know how you're actually supposed to pronounce it. That's just how I pronounce it. And then I ordered the PCBs through PCBWay. It's like $5 and they ship them in pretty much a day or two, and you get them probably within like 7 days. You'll get them. So really nice, really fast, very cheap, which is what I was going for here because rapid prototyping. But yeah, I think that's gonna do it for this engine. I may experiment with turning up this voltage a little bit to brighten up the lights, but for now, I think I'm just going to screw this thing back together, pop the shell on in the reverse order of that, and I'll get some footage of this operating on my friend's layout when I'm there for an operating session next. But yeah, thing's pretty sweet. So there you have it. That was my Blunami install on this Atlas O SW9. And this engine's really nice. I like switchers, I like small engines, but this thing, with the sounds that it has now, and especially with the low speed control that it has now, this thing is really nice. Blunami is great with like low speed operations. We don't really have that in 3-rail O. Like Legacy Odyssey speed control or Odyssey 2 speed control works really well. And so does the Electric Railroad, the back EMF system that they use. But I think this would beat both of those in low speed operation. That's part of the reason why my friend and I decided to have this engine be the demonstrator, at least for him, for the Blunami system, is that he uses switchers a lot, and low speed operation lends itself really well to a switcher. So that's why it's in here. And unfortunately, with that also comes electrocouplers. But I got to invent a board that controls the front and rear electrocouplers independently, and you can use either the toggle or the momentary feature, and it throws it just the same. So that was a lot of fun. Got to learn a lot about electronics doing that, and circuit board design, and finally make my own custom PCB, which I wanted to do for a while and just never really had a reason to do it. So yeah, I hope you all enjoyed. I hope you all learned something. If you guys have any questions about what I did or how I did it or why I came to the conclusions I did or how much stuff I messed up, feel free to drop a comment down below and I'll be sure to answer you guys. I love chatting with you down there, so look forward to reading those. Anyway, I hope you all enjoyed. I'm CW Hollow One, and have a good day, or maybe good night in your case. See ya.